Hello everyone, welcome to another episode in the series of Python programming for GIS data processing in QGIS. So in this video episode, we are going to discuss the topic on functions. So this is the file I'm going to walk you through. In this file, you have everything you need to know at least about functions in Python programming. So as usual, I'm going to open it up in a text editor where we are going to have more space and more visual to read the content and make use of it. So let me open it up in the text editor. So with the script opened up in the text editor, all the content are about functions. So functions are actually an important concept in any programming language, not just Python. So a function is simply a block of code which runs when it is called. So you define block of Python statements or chunk of Python statements within a block of code, and then you give it a name, and then you decide to call it to run that block of code or that chunk of code at any point in time within your program. So here, functions are basically categorized or divided into two types. We have the built-in functions, and then we have the user-defined functions. So all this while you have been working with built-in functions. And some examples of the built-in function you have used are the type function, the dir, the help, the print functions, and so on. So there are so many of them. If you recall, in the previous videos, you did something like this, maybe print hello QGIS. So just by doing that, you have used the print function. So it's a function that simply prints out a string or a text on the console. So that is an example of a built-in function. So, and there are so many other ones as listed on this page. So let me open up this URL to see the list of all the built-in functions in Python. So on this URL, you can find the Python interpreter has a number of functions and types that are built in. So you can see that on this page, you have plenty of them. And here they are organized alphabetically. So there are so many of them, and already we have worked with some of them. Like this dir, we have made use of it. The length function, we have used it before. We have used float, format, and so on. So on this page, if you want to take a look at the explanation or the description of what the function is, you just simply click on the link, and then it will take you to the section below the page. So a function like the range function, if you click on it, it will take you to the section where you have the range function explained or defined. So all these are the built-in functions in Python. Before we move on, I think it would be a good idea if I can walk around or play around with the functions, the built-in functions, before we start defining our own function. So in Python, there is a function called locals and globals. So these functions, they have the capability of listing the current data structure or the symbol table of your compiler. So if you launch the Python interpreter or the Python compiler, Python automatically defines some of these built-in functions, and they are there for you to work with them. So let's play around with it to see what we can get. So the content of the locals or the globals will vary depending on the Python environment you are working on. So here I'm going to use the QGIS environment, and then if you try it on a different environment, you see that you have different result to what I'm going to get here. If I copy this to the command line and then execute it, then I need to check the content of the variable I define the locals for. You'll see that we have numerous entries there. So if you do this on a different environment other than the QGIS, some of these variables and functions will not be present. So I can quickly check the type of the variable I defined. If I do that, I can see that it is a dictionary. So which means that we can check the keys, and also we can also check the values. So I'm interested in the keys for now. So the keys, you can see that the keys are made up of functions, classes, methods, variables, and so on. So all these are the locals that we have available to work with in this Python compiler. So if you define a local function or a variable, it will be listed in this local function. So actually, the part that contains the local variables and methods and functions that you are currently working on in the environment is located in this built-in key. So you can check the built-in key, and then you see that the built-in key is also a dictionary. So if you check the type, you see that it's a dictionary. Yeah, so the class type is a dictionary. So it means we can also check the key. So if I copy that line with the key, and then you see that we have the keys. So the keys are made up of all the built-in functions, the classes, and so on. So these are available for us to work with, even though we did not define it ourselves. So this is a concept called abstraction in object-oriented programming. So you just work with a function or work with something that you don't bother to know how it was defined or how the working principle is. So let me open up a different Python interpreter and then check the locals so that you will see the difference from what I'm talking about. So if I go to the command line, I open the CMD command line on my Windows machine. So if I open up, if I start the Python interpreter, then here I can do, like, I can call the locals. So I'm calling the local function, and then you can see that the local function returns a dictionary that contains other methods and functions. So the one we're interested in is this, and then as you can see, it's a built-in module. So what I can do next is to check the type. You can quickly check the type of the local method I just called, just by enclosing it in the type function. So type is also a function that returns the type of an object. So the locals is a dictionary. So it means if I go back and say locals.keys, so keys is also another function, or this time around we can call it a method for dictionaries. So this return the keys of a dictionary. So we're interested in these built-ins. So it means I can say locals, then open and close brackets, and then within it I will now call the name of the key. So double underscore, then built-ins, then another double underscore. Oops, I think I made a mistake. So key is not scriptable. Yes, I need to remove the key method. I need to remove this first. So you can see this is a built-in module. So for us to see the content, I can use another built-in module, which is the dir. So the dir will list all the methods, the variables, and all the classes within an object. So this time around, it is listing all the classes and the functions and methods within the locals, within the local function on the built-in key. So here are all the locals that are defined in this instance of the Python interpreter. So as you can see, the content here is quite different from what you got in the QGIS. So in the QGIS interpreter, we're able to get other uh, functions that are peculiar to just the QGIS environment, like the QGS, the QS, any of these names that start with QS, QT, PyQt, they are all peculiar to the interpreter here in the QGIS environment. So let's go back to the notes. So just feel free to play around with the locals. You can also do the same thing for the globals. So the locals are for the locally defined data structure or the symbol tables, while the globals are for the globally defined symbol tables. So that is that about built-in functions. So we have been working with them before now. So now the focus on this video episode is actually on user-defined function. That's the function we are going to create ourselves. So to define a function, the syntax is just as follows. You use the def keyword, then followed by the function's name. Then optionally, you can define a document string, and then you can have any amount of a statement indented within the function block. So, and if you want to call the function, you just call it by the name. So this is the simplest syntax for defining the function. So let me take it to the QGIS environment and paste it. So if I run this, you see that I think we have an issue. Yeah, we have an issue. So this is supposed to be in parentheses. It's supposed to be in parentheses like this. So this is my bad. I'm using Python 3 interpreter, not Python 2. On Python 2, you don't need this parenthesis, but on Python 3, you need it. So if I run it, you see that nothing happens. Ideally, you should expect that this line should print this statement. But if you run it, nothing happens. This is because here we only defined the function, but we have not called it. So if you want to call it, you need to call the name together with the parentheses. So you can call it here, and then it will now print something for you. Or you can have the function call outside the function code block, just like this, and then when you run it, it should print out the statement for you. So you can change the statement, maybe something like hello function in QGIS, and then when you run, it should print out hello function in QGIS. So this is a simple way of defining a function. So let's go back to the note. So before we move on, let's quickly take a look at the difference between a function and a method. So most of the time, you find out that people usually confuse or use the names interchangeably. So in the technical sense, there is actually difference between a method and a function. So a method is simply a function that is defined inside a class. So the idea of creating a class and then defining a method is actually beyond the scope of this video. So in this video, we are going to limit ourselves to just functions and working with functions. But you should know that a method is also a function. The only difference is that it is defined inside a class. So when you define a function inside a class, it is called a method. So it means that all methods are functions, but not all functions are methods. So the easiest way to find out whether a built-in is a function or a method is by considering something like what we have in this example. If you take a look at what we have here, if you call a function with the dot operator on an object, so it means that function is actually a method. But when you call a function and then you supply uh, argument into the parentheses, then it is actually a function. So a typical example is the upper method on strings, and then the length function. So length is a function, while upper in this case is a method. So later on we are going to take a look at how to create methods in object-oriented Python classes. But here we are going to focus on just working with functions. So functions have the capability of taking in parameters, and then when you call them, you supply arguments. So parameters are the variables you list inside the function, inside the parentheses of a function when you are defining the function. So parameters will be added here, while arguments are going to be added when you are calling the functions. So there are several types of arguments. We have the default argument, the required argument, the keyword argument, the variable number of argument. So later on we are going to see more about them. So let's actually create a function that takes in a parameter, and then we can supply argument to it when we are calling it. So here's a simple function. So this function actually just print out the statement that says loading the version of QGIS or of whatever string you entered here. So if I copy it here, delete this. So if I run it, as usual, nothing will happen because we have not called it. So here I need to call the function, and notice that this function, the name is opening GIS software, and then it has a parameter which is version. So and that version needs to be provided at the point of call, which is an argument in this case. So I'll just use maybe a number, maybe 3.22. So if I call it and then supply the parameter as an argument, you see that it will print out this statement that says loading QGIS 3.22, please wait. So if I want to do it for other version of software, if I want to call it several times, or for other version of the QGIS software, all I need to do is just to call the function severally, just as I've done here. If I copy it back here, if I paste and then run, you see that it calls the same function multiple times with different arguments. So this is one advantage of creating a function. So you can create a function and then call it as many times as you want. So if you take a look at inside this function, I actually added a triple quote, a string within a triple quote. So this is called the doc string or document string of this function. So you can actually access it by using a special method called the underscore underscore doc underscore underscore. So if I copy it back to the QGIS environment and run it, you see that it prints out the document string. So this document string is actually optional, and I I know that in most of the functions you come across in textbooks or in online, you will see that most of them will not have this docstring, but it is actually an important part of a function, especially when you are going to create a function that you are going to share with other developers. So it is a good practice to have a docstring that explains what the function is going to do. So it's more or less just like a comment, but it is not a comment in the sense that it has the ability of being accessed using the special dunder method called the underscore underscore double underscore doc double underscore. So let's move on. So from the function above, we are not able to change the name of the software. So here I defined the same function with multiple parameters this time around. So here we have more than one parameter. So you can have as many parameters as you want. You just need to separate them by comma. Just do I have it here. So here I'm able to define a custom name for the function, for the software in the OpenGIS software function. So here it means the function doesn't need to load QGIS all the time. You can load other version of GIS software, other type of GIS software. So as you have seen here, so if I copy it back to the QGIS environment, if I paste it, you see that the function takes in multiple arguments or multiple parameters. And then when you are calling the function, you call it with the multiple arguments. So if I run this, you see that the same function is loading QGIS. It loads GRASS version 7.9. It loads Saga version 2.6. It's also loading ArcGIS Pro version 2.8. So this is the benefit of a function. So if I'm not going to use a function, then it means I have to repeat this print line separately for each unique software and version. So but with a function, you can define the multiple arguments and then call in the arguments on the parameter as you want. So let me quickly show you something. If, for example, we decide to call the function without the argument, let's see the kind of error we are going to get. So if I call it with this argument, for example, if I say this, let me say this time around, let me change it to global mapper. Global mapper. So it is calling global mapper, let's say version 20.55. So you can see it works perfectly. So but if I decide to call it without the argument, if I remove all the argument and just call the function the way it is, you see that we have an error. And the error says OpenGIS software missing two required positional arguments, name and version. So these are actually positional arguments because the name and the version were defined as parameters here. So if I go back, if I try to just put 55 to call it, I still have a problem. So the error now is saying that missing one required positional argument, which is the version. So if I go back, if I enter just another random number, it works. But as you can see, 55 cannot be the name of a software, cannot be name. While 90 can be a version. But in this case, it doesn't care. Whatever you give it, that's the way it will work. So the first parameter you supply will be given to name, then the second will be given to version. So that is why it is called positional argument. So if, for example, I decide to interchange the names, let's say this QGIS, if I decide to interchange the name of the argument, so 3.6 is coming first before the QGIS string, you see that it will still work, but it has interchange them. So if you really want to be sure, want to make sure that you are maintaining the same argument for the parameters defined, then you have to call the names of the parameter when you are calling the function. So for example, what I have here, so this will now be version is equal to 3.16. Then the name will now be equals to the string QGIS. So if I do this, I will get the correct output. So that is what is meant by keyword argument and positional argument. So let's go back to the notes. So the next thing we have is another example that defines a function that takes in more than two arguments. So more than two parameters in this case. And then as you can see, more than three arguments are defined as apply when we call the function. So let me go back to QGIS environment. I'll clean up that, paste the new function. So the new function, the name of the new function is called that long elevation. So it takes parameter, latitude, longitude, and then the elevation. And then it simply prints them out. So as you can see, if you have to call the function, you need to supply the latitude, the longitude, and the elevation. So if you interchange the value, for example, let's say we took the value of elevation and then brought it to we bring it to the beginning. So it means this value will be given to latitude, while this will be given to longitude, then this one will be given to elevation. Of course, you know that there is no latitude that is 982 in value, 982.89. There is no such latitude in the world. So if you do that, you see that you have a different output from what you have in the beginning. So to make sure that the correct argument are given to the correct parameters, then you need to supply the name just like this. For example, if you want to make sure that this is elevation, just say elevation is equal to that, then automatically this will go to the latitude, then this will go to the longitude. So you need to call them. Latitude is equals to that, then longitude is equal to that. So if you run it now, you see that you have the correct latitude, longitude, and then the elevation are put it correctly. So let's assume you decide to remove one of the parameters and then you run. Let's see what will happen. So you can see you have an error now that says syntax error. Positional argument follow a keyword argument. So you need to define all the keyword arguments first. Start from the beginning. So you cannot define an argument that doesn't have a keyword after you have defined an argument with keywords. So automatically this goes to the latitude. Then of course this, because you have assigned it to elevation, it will go to elevation. And then because you have assigned this one to longitude, to go to longitude. So if you don't want to define the keyword parameter for this argument, then you have to bring it to the beginning. You cannot take it to the end. So let's move on to the next example. So in the next example, we are going to see how to use a arbitrary number of arguments. So instead of explicitly specifying the number of arguments you want to call, you can use this keyword *args to define an arbitrary number of arguments. So by convention, we use *args, but you can actually use *whatever, and then this will allow you to take a tuple of element into the function. So let's copy it to the QGIS environment and see how it works. So here we define the function large long elevation. So instead of giving it the parameter large long elevation like we did previously, we just use the keyword star args, and then it will take any number of uh, arguments as a tuple. So if I click on run, this should print the entire entry. So you can see it is printing, or it is returning a tuple. So with this, it means we can give any amount of values. Let me add some more, just like that. And then if I process it, if I run it, it should print out all of them. So instead of manually or explicitly typing the argument, if you don't know the number of elements or number of parameters or arguments that your function is going to take, so you can use this star args, and then it will take any arbitrary number of arguments, as you can see. So you can take 1, you can take 2, you can take 100, you can take any amount. So this is dynamic. So let's go back to the notes. So in the notes, the next thing we are going to take a look at is the keyword argument. So already we have discussed the keyword argument. In the keyword argument, you just need to define the keywords, and then in the parameter, and then also you can define the keywords in the argument when you're calling the function. So it is also possible to call an arbitrary number of keywords. So instead of calling elevation, or that's a latitude, longitude, elevation, you can decide to use the star quarks. That's for keyword arguments. And just as I've mentioned earlier on, that the word args is just by convention. You can actually use whatever you want to use here, as long as you have this star here. So the same thing is applicable to this. This will take in a dictionary of key and values. That is what is called a keyword argument. So by convention, we use quarks, but you can also use whatever you want to use here. So this will take in dictionary, while the other one takes in just a single entry, single words, or single text or numbers. While in this case, it takes keywords. So as you can see here, if you try this example in the Python environment, if I run, you see that because it is a keyword argument that was passed as the parameter. So when you call the argument and supply the keyword argument, you can use the for loop to loop over the items, since it's not a dictionary. And then you can see that you print out the dictionary with each keyword corresponding to the value provided, as seen. So if you wish, you can change this. Instead of using quarks, you can change it to anything, maybe just XX, and then everything should work as the same as the previous. So by convention, we use quarks and args. So another example is this. So in this example, I am passing in a dictionary. So here I have a dictionary called coords. So it's just a coordinate that has, it's a dictionary that has the key latitude and the value, then the key longitude and the value, then the key elevation and the value. So you can pass in a dictionary if you use the star quarks parameter, and then everything should work as expected. So you can see that when you are passing a dictionary, then you need to assign double star to the name of the dictionary. So the next thing we are going to take a look at is returning value in a function. So all this while we have been printing the result of the function. So if you want to make use of the value that a function returns, or you want to carry on with calculation using the result of a function, then what you need to do is to use the return keyword. So when you return the value of a function, you will have the ability to carry on with your normal calculation or your normal processing. So for example, if I do this, if I run this, then I can call the function and then provide the two arguments, maybe 2, 3. So this will return 2 plus 3, which is 5. So if you want to continue operation with this, for example, I can call the function, then maybe add 5 to it. So this should return 10. So I can easily do this. But if had it been this is no return, let's assume that here is a print statement. So the function is just printing it. It's just say print x plus y. So if I do this, if I call, it should print the result. But if I want to perform operation with it, and then I add 5 to the call of the function, so I should have an issue. I will have an error. So what if I use the return statement, everything should work perfectly as expected. So that's the benefit of using a return statement in a function. So return statements allow you to continue to work with the result of your function. So here is another example. This function takes in latitude and then it returns the sum divided by the length. So latitude is actually a list. So it's expecting a list of latitudes and then it finds the average. So that's the average function. So as you can see, if I copy it back to the QGIS environment, then I run it, you see that the function takes the list of latitudes and then it finds the average. So the sum of all the entry of the list divided by the length. So the length is just the number, the count of the items within the list, and that will give us the average. I'll go back to the note. So one important thing to note about the return statement is that the return statement should be the last line within your function code block. So anything that is called after the return statement, the Python the line will not be executed. Python interpreter will ignore it. So here is an example. In this example, you can see that the function is defined. They will have a statement that prints before the return statement. They will have a statement that prints after the return statement. So this statement will never be executed because the function has encountered a return statement. So if you define a function, the return statement should always be the last thing, always be the last line within your code, within your function code block. So if I test it out, let me call the function outside the code block. So maybe I will just call it with maybe 4 and 6. So this should return 10. So you can see the function ran. The statement before the return was printed out, but the statement after the return was not printed out. If I copy to the console, I run it, you see that it's still the same thing. So the reason why it is not printing out is because the return statement doesn't print out. So if you want the result to be printed out, you have to call the printf function on the function call. So what if I cut the return statement down below the two print functions, you'll see that both lines will be display. So both lines will be executed. So the return statement should always be your last line of statement within your code, your function code block. So take note of that. So there is also the concept of anonymous functions. So these are functions that are called lambda in Python. So they are called lambda because they make use of the lambda keyword to define the function and not the def keyword. So lambda functions are just functions that are anonymous. They don't have name. And usually you make use of such functions when you want to quickly use the function maybe just once within your script and throw it away. So if a function, if at a point within your program, you only need just a function to run just once. So you don't need to use the def keyword to define a name for a function. You can use the lambda, which is just an anonymous function. And you can make use of it to run your code block. And then once it is done, it throws it away automatically. So it doesn't keeps the name in the memory. It helps save space within your memory and makes your program run faster. So a typical example or scenario where the lambda function is used is when you are working on, when you are using a function like the filter function, the map function. And personally, I usually use the lambda when I need to apply a function to pandas series or pandas data frame. So these are typical examples where the lambda functions comes to play. So here in this example, we have the lambda function apply on the filter function. So the lambda function is usually defined using the expression starting with the lambda keyword, then the arguments, then a column, then you have the expression at the end. So everything is usually on a single line. So here you have the filter. So this in this example, we have elevation lists. That's a list of elevation data. So we want to use the filter function to filter out the elevation that is greater than 100 or 1000 meter. So using the lambda, we can quickly define an anonymous function that filter out or that use the expression of greater or equal to or less than or equal to 1000 and then apply it on each and every element within the elevation list. So as you can see, the filter function takes a function and then apply it on a list. So the entire result is now converted into a list. So as you can see, we made use of the lambda function here. So if I copy it back to the QGIS environment, I'll delete this and then I'll paste. You see that we have a list and then we have the filter applied to that applies a function to the list. So this filters out all the elevation that are greater or equal to 1000. And as you can see, we have 1, 2, 3, 4 elevation that are greater or equal to 1000. If I change the expression to less or equal to 1000, we should have a different result. So as you can see, we have the following result as less or equal to 1000. So this lambda function can actually be replaced by a normal function. And that is what I have in the next line of code. So I defined the function that replaces this lambda function. So instead of what we have here is the same thing as what we have above. If I go back, let me just remove this and then paste. So instead of having the lambda function, I just defined a function name elevation above 1k for 1000, and it takes one parameter, then it returns the parameter less than 1000. less or equal to 1000. So this function name, I'm now applying it. I'm using the filter function to apply it to every element within the elevation list. So if I run it, you see that I have the same results to what I have previously. If I change this to less than or equal to 1000, you see that I have the same. I have the same results as what we have previously. So as you can see, the results are just the same. So basically, instead of defining the function like this, since I just need to apply the function to just the filter function on the list we already defined here for the elevations. So I can quickly use an anonymous function, which makes sense because after using it, the script automatically throws it away and it doesn't save the name. It doesn't keep it in memory. So let's go back to the code example we have. So the next thing in our note here is this example that sums the squares of latitude and longitude together. So this is just another example. If you look at what we have here, if I copy it back to the QGIS Python environment, you see that if I run it, let me see, nothing happens. Yeah, let me go back and check. So here I'm supposed to save it in a variable. Maybe I will just call it new lat.long. Then I'll print it out. So if I copy it back, move this paste. So if I run it, you see that here we have a list. The list is called lat.long, and the content are actually tuples. So we have a latitude, longitude, then comma another set of latitude, longitude, comma another set of latitude and longitude. So here we use the map function to use a lambda. The lambda will take the first entry, then the square of the first element in the first entry, which is the latitude, then plus the square of the second element in the first entry, which is the longitude. So as you can see, the parameter is just 1, and then the parameter is going to be this tuple. So the first index, the square of the first index plus the square of the second index. Remember that index starts from 0 in Python. So the first will be 0, then the second index will be 1. So if you find the squares or the entries, then add them together and then keep the results in a list. So that is what we are doing. So map is also another function that is similar to filter. Filter filters out the records, while map takes a function operation and then applies it to every element in the iterable. So here we use a lambda function to do that. So similarly to what we did previously, we can also define this lambda as a normal function, as seen here. Instead of using the lambda function here, we just defined the function that does that and then apply it to the lat.long list. So I can quickly do this here, and then if I copy it back to the QGIS environment and run it, you should see that we should have the same result. So paste. So if I run it, you see that the same output as the previous one. So basically, map the map function applies a function to an iterable. So in this case, the iterable is a list. It's a list of tuples. So unlike filter, filter will filter out either the largest number, the biggest, the smallest number, or the numbers that meet a condition that are greater than or less than certain value and so on. So just as the name implies, filter. While in the case of map, map will take a function and then apply it on every element within the iterable, either a list or a tuple or even a dictionary and so on. So let's go back to the note. So what we have next in the note is nested functions. So I'm not going to talk much about this in the sense that it is a little bit complicated and is beyond the scope of this video lesson. So, but what I would like you to know about nested function is that a function has the capability of taking in a function. That's a function, you can call a function within a function, just as we have done with for loops, where you can call loops within loops. So functions too, you can call a function within a function. And this is just a typical scenario. And if you want to learn more, you can go to this URL and then you should learn more about a nested function. So also, a function can also call itself. So assuming this is outer function. So within the outer function, within the code block of outer function, you can call outer function within it. So if you do that, what you are doing, you are doing what is known as recursion. So recursion too is also another programming concept that is outside the scope of this video, outside the scope of this lesson. But you should be aware of this kind of scenario that a function can call itself. So in this case, you are using a function to make a loop until a condition is met. So the function will continue to call itself until a particular condition is met. So that is what is known as recursion, and it's an elegant way of handling some mathematical and programmatical scenarios, such as when you are doing a greedy search algorithm. So it's a very good way, and also the mathematical Fibonacci sequence recursion are very well utilized in such scenarios. So with this, I think I've come to the end of this lesson on functions, and I hope you enjoyed it, and hopefully you are going to make use of functions henceforth. Thank you and have a nice day. Bye bye.